to take a photo, and I think she sent the photo to the group for all of you. And the quality of the photo is better than here I have. But you can have a, so we have a two method for HDL. One of them known as a macro, one of them is a semi-macro. For macro, we need 500 microliter of sample. For semi-macro, 200 microliter. Then we will add HDL reagent. For macro, undiluted. For HDL reagent, diluted, 500. Then they should be incubated for 10 minutes at room temperature. And we have to centrifuge 10 minutes at 4,000 RPM. After that, we just need supernatant. I will ask my colleague and also check with them to do that part and provide a supernatant for the student. And you don't need to do this part. They give you the supernatant. For the next step, you need two tubes for HDL measure. One for blank, one for sample. For blank, you just add 100 microliter of distilled water, DW, distilled water. For sample, you will add 100 microliter of supernatant from previous step, which my colleague gave you. I think we don't need that, but let's increase the brightness. So you have a two tube, 100 distilled water, 100 supernatant of HDL. Then you will add a cholesterol reagent. 1,000 microliter is equal to 1 milliliter, 1 ml. 1 ml is 1,000 microliter. Okay? So you will give them time. If water bath incubator was turned on at 37, you need 10 minutes. But if you didn't have access to the water bath, you can incubate at room temperature for 20 minutes. So after 20 minutes at room temperature, you will go to the spectrophotometer and read the absorbance at 546 nanometer. You will measure the absorbance of blank, absorbance of the sample. The delta A here means the absorbance of sample minus blank. But if my colleague set the machine by blank on 0, you have just ODR sample. Instead of delta A, you have an A, absorbance. Absorbance multiplied by factor. Factor for macro is a 274, for semi-macro is 320. We should ask them which kind of method they used for providing supernatant, and after that you have to divide it by that. I think they use semi-macro, 320, it should be used. So the absorbance multiplied by 320 give you what? The HDL cholesterol concentration based on milligram per deciliter. Is the first one. And the normal range for male more than 55, for female more than 65. Also in the lab, if you were in the lab and you did this test by yourself, if the concentration of cholesterol was more than 200, because it's out of linearity, you need to dilute some. Remember that for all the time, for all factors, when one factor concentration was so high, you should to dilute it and again read the absorbance. Then finally you have to multiply by the diluted factor. What? Sandra? Okay. It was HDR. The next one is a triglyceride. The quality here is not good because I actually take a photo and photo wasn't good. But what you need to know about the triglyceride measurement. For triglyceride, we have reagent number 1 and reagent number 2. The reagent number 1 has an enzyme concentration and reagent number 2 has a buffer. What enzyme we need? The lipoprotein lipase. Triglyceride by lipoprotein lipase convert to the glycerol and free fatty acid. Then this glycerol from the previous part by ATP by glycerol kinase convert to the glycerol 3-phosphate. Glycerol 3-phosphate by oxygen by glycerol phosphokinase oxidase. Glycerol phosphooxidase. Convert to the H2O and actually other components. This H2O2 by amino antipyrin by peroxidase convert to the quinoline. This quinoline, the color is blue. So the intensity of the blue color is equal to the amount of triglyceride. If triglyceride be high, the intensity of color is high, the absorbance at 546 is high. So is the basic of the actually reaction. And we have a reagent number 1 and reagent number 2. My colleague prepared reagent, one part of reagent number 1 by 100 part of reagent number 2. Provide the triglyceride reagent. Actually, they prepare the triglyceride reagent on your table. So what is the procedure? Procedure, you need 3 tubes, blank, standard, and sample. Guys, if you ask anything in the lab, I will kick out you, okay? Blank, standard and sample, you need 3 tubes, okay? For the blank, we just add 1000 microliter of working reagent. This working reagent, triglyceride reagent, my colleague give you. To all of them, we add 1000 microliter of triglyceride reagent, or 1 ml of triglyceride. To the standard, we add 10 microliter of the standard. To the sample, we will add 10 microliter of the sample. What kind of sample we have for triglyceride measurement? Sample. Serum. Thank you. For measurement of all lipid factor, we use the serum. So, my colleague provides serum actually. They take blood and centrifuge it and separate serum, and they give you the serum. So, be careful. When here wrote 10 microliter, you should take 10 microliter. If you take more, the OD is more, the concentration is high. If you take less, the OD is less, and concentration also is low. So if you get the wrong result, it's because of your sampling. You couldn't, or you weren't able to take the right amount of the 10 microliter. So after that, we have to incubate at room temperature for 10 minutes or at 37 water baths for 5 minutes. I would ask them to turn on the water bath, but I don't think so. It will be ready. You can incubate at room temperature for 10 minutes. After 10 minutes, by measuring at 546 nanometer, you have a sample, a standard and blank. The OD of sample minus blank is delta A of sample. OD of standard minus blank is delta 1 absorbance of standard. If we set the instrument by blank on 0, you have just OD of sample, OD of standard. multiplied by concentration of a standard. How much is it? 200. So the OD should multiply by 200. And then it will give you the triglyceride concentration based on milligram per deciliter. The normal range is 36 to 165 milligram per deciliter. So if you get, for example, 5 or 0.2, it's wrong, exactly. But if you get 1000, maybe it's correct. This patient has a hyperlipidemia. When you get the result out of reference range all the time, you have to do again the test. And you must be sure about the result, about your report. Actually, in the lab, we do these tests, all of them, by the machine, automatically. And we have to all the time check the result. And if the result was out of the reference range, we have to recheck that. We call it delta check, 2 times or 3 times. And we have to look at the previous data of this patient. If it was similar to the previous, it's good. But if it wasn't similar, we have to find the reason. Maybe this time has a problem. Maybe our result is wrong. And we should find out that. So it's the second experiment and triglyceride measurement, and it's finished. Everything is clear right now? Great. Ratio? Ratio what? The range, normal range or ratio?
Ratio.
LDL to HDL ratio? Ratio. We don't have ratio here. HDL to LDL, I will talk about it at the end. LDL to HDL ratio. I didn't reach it that. For cholesterol, actually, again you have a 3 tube, okay? The standard bland test. In a standard, you will add a 10 microliter of a standard. In sample, 10 microliter of serum. In the actually bland, 10 microliter of distilled water. And then you will add the cholesterol reagent, 1000 microliter or 1 ml to all of them. Then give it time. Incubate at 37 for 5 minutes or at room temperature for 10 minutes. And we will measure the absorbance at 546. Then delta OD of sample, or means the OD of sample minus bland. The OD of a standard minus bland. Okay? So OD of a standard divided by OD of sample divided by OD of a standard multiplied by concentration of a standard, which is 200. It will give you the cholesterol, total cholesterol concentration based on milligram per deciliter. So till now, we measure triglyceride, total cholesterol, and HDL cholesterol. So total cholesterol is equal to the LDL cholesterol plus HDL cholesterol plus what? VLDL cholesterol. So the cholesterol amount inside the VLDL, LDL, and HDL is equal to the total cholesterol. Here in Iraq, we couldn't find the kit for measurement of LDL directly. But as I mentioned in the theoretical part, we have a formula which is known as a Friedwald formula of equation. This formula, we can measure LDL based on knowing the total cholesterol, HDL and VLDL. Actually, we do not measure VLDL cholesterol directly. We measure triglyceride. But all the time, triglyceride divided by 5 is equal to the VL. This formula is correct for those patients the triglyceride amount is less than 200. 400, sorry. If the triglyceride was more than 400, this formula is wrong. We can't calculate LDL. And we have to measure LDL directly. But if it was less than 400, we can use this formula. Based on this formula, the LDL cholesterol is equal to the total cholesterol minus HDL cholesterol minus triglyceride divided by 5. And it will give you the LDL cholesterol based on milligram per deciliter. So right now you have a concentration of LDL, total cholesterol, HDL, and TG. Finally, at the end of the session, you will divide the concentration of LDL to the HDL, and it gives you the number. This number, if it was less than 3, normal. Between 3 to 5, medium is more than 5, high risk. And you should report these numbers also. It's the whole experiment today. So, if you have any question, it was a ratio. You got it? And LDL to HDL ratio, the best value is less than 3. So it was the whole, actually,
هو اللي كنت عليه إذا أنا قلت وين حجر؟
Yes, the first group can go to the lab right now. But if you didn't understand right now, let me know, I will explain it. When you go there, you don't have right to ask any question.
طالعين ذني الأصحاب وطالعين هذا من حساب ذني طالعين هذا. HDR والكوليسترول.